I'm Henrietta Dombrovskaya. I work as the data architect at DRW Holdings. It's an international company. We have offices everywhere, including London, including Amsterdam, but I am in Chicago office. And my other job, which I actually hold, while I had 5 different day jobs, I'm a local organizer of Chicago PostgreSQL user group. So I've been there for quite a while, as I mentioned. So I always like good speakers. So if you happen to be in Chicago, let me know, and not the last minute, okay? I will be happy to have you as a speaker. And we'll always have pizza and beer. And also, I'm a local organizer of PG Day Chicago. So we had 2023, 2024, and I really hope we have 2025 and going. So once again, if you are interested and help me, let me know. Okay, so what's next? So talk about pgBadger. Why and why we love it? Let's start from why we love pgBadger. So first question, anybody here never used pgBadger? Hands? Okay, there are some. Okay, who did use pgBadger? Yeah, all right. So if you did not use pgBadger, you either do not support anything in production or you just do not know that you should use pgBadger. It's like absolutely amazing tool because what it allows you to do, it allows you to see what's going on in the database. It produces tons of reports. So you need to turn logging on, by the way, like log mean duration 0, but when you do this, it tells you everything what's going on. So to give you example of like traditional pgBadger, because we will tell in a moment what was missing, but like traditional pgBadger report looks like this. That's the first page. So here you can see that, okay, so we recorded from this moment to this moment, we had that much traffic. We had, we know what were the fastest queries, what was average query execution, your read traffic, your write traffic, all lots of valuable information. And also, what is more important, you have details about your queries. And not only what was running the longest, but things like, okay, which query was cumulatively the longest, maybe a relatively short query, but runs most often, so take most times, what are like normalized those queries, lots of other valuable information. So as I said, if you did not use it, like start using it. Honestly, like you would not regret. Again, we love it, we use it. I used it, I think, like for more than 10 years, like from very, very early versions, in all the companies where I worked and I used Postgres. What is missing, or rather was missing, because we fixed it, but I don't know whether anybody, used it like me very often. What you were missing? Anybody? Yes. What did you miss? What is? Flexibility, okay, yeah. Flexibility, that's right. And I can tell what exactly I was missing, but that's kind of relates to flexibility. I wanted to be able to see what individual session is doing. Because, for example, you have this situation, okay? You have most frequent queries, and you have a lot of commits and begins, and since you do not have enough inserts and updates, you kind of suspect somebody is doing some ORM, is doing something not exactly right. But you cannot tell it to developers because you come, no, I don't know where you found it. I don't know, it's not me. So I always wanted to, okay, that's you, and that's what you've been doing for 10 minutes. And I was not able to do this, and I was trying all monitoring tools in the universe. I talked to developers. I tried to do it with Datadog. I tried to do it with New Relic. New Relic actually is very deceiving because they say they record everything. Actually, they are sampling. And you can see some of them, but you cannot see this session which you need. So I was kind of like desperate, because I really need it. I need to put it in the developer's face. I love developers, I love working with developers, but sometimes you just need Yeah, go fix it. Right? Okay, you know, my favorite phrase, I know it's kind of in Floor's books, I think, right? What developers say, everything works fine until application hits database, right? So database is a problem. So we always need to do otherwise, to prove otherwise. So I was like, okay, so I knew there should be an answer. So I kept trying, searching for the tools, and just what to do. So my thought, okay, so if we do actually log mean duration 0, technically speaking, we have everything, but who tried to search for these PID in logs? Somebody tried, right, because you are desperate. And you know how long it takes, and so what can be? How can I just take this log and map it to the database? And you think it's easy, it's not. So actually, I found a log4 in data wrap. I thought, oh, okay, this will do it. This will map my log to the database. I tried it, installed it. No, it actually does not parse anything in the statement. So you cannot do much with this. It's just your time stamp, PID, and that's it. What I'm going to do? So I need to parse and okay, actually, pgBadger parses the log records before it creates a summary report. So how about I will take this parsing? That was a brilliant idea. And then I asked, okay, so I cannot steal parsing from pgBadger. I need to ask nicely. So I asked, Leticia, can you introduce me to Jill Zerald? And she's like, yeah, but you know what? He's so shy, he might not want to talk to you. Give it a try. So she like message, okay, hey Jill, that's Hetty. Hey Hetty, the Jill said, oh yeah, Hetty, nice. I was like looking forward to meet you. And I like, okay, Jill, I want to do this thing. And you're like, I can provide you any extra reports. I'm like, no. I do not want your extra reports. I want to report myself. Can you give me raw output? And he went silent for a week. And like, oh my gosh, what did I say wrong? I offended him. He like didn't. And in a week, he like, hey, Hetty, check this last commit. Like, eee. So we actually got it. And then there was a month of very intense debugging because I tried and I said, oh, this does not work. Then we like discovered corner cases. So people who are following pgBadger on GitHub they started to message, Hetty, what are you doing? But then finally, we got our pgBadger magic, which I'm ready to introduce. So the rest of the talk. So we will look at the changes which were made to pgBadger and how we can use them, how we can automate log processing, how we can actually use it for things, and what does it take in terms of resources, and what we want to do next. So first of all, new pgBadger features. Actually, there were two features. You know what? When they came live, what I started to see on social media, oh, I never knew pgBadger has this. It's so cool. I'm like, yeah. I didn't have it a month ago. Now, yay, here you are. So there are actually two new options. One option, dump raw CSV. So what it does, instead of producing HTML, it does produce, but it's empty. You can direct this output into CSV file, and it will actually like give you the CSV of this log. And the other important thing is log separator, because by default it's comma. Comma is not really helpful when you parse logs. So what I usually do, I do log separator #, which kind of like the safest, let's say, not without an errors. And then you produce CSV log, which you can do what? All right, now you can load it in Postgres. And now, so look what happens. So that's your log, right? And yeah, Leticia tried to search in this log and this PID. But now, instead of this file, you see that. And what you can do now, you can do select. And you can do it select whatever you want. Find whatever you want. Do any analytics you want. So that is quite amazing. So thank you, Jill. Again, I know he didn't want to do stuff with me, but I'm still immensely thankful to him. All right. So what we can do with this table now, which is not just a log, it's a table. So several usages. So first of all, as I said, session tracing. Now we can here developer. That's what you are doing. Then you can trace events which happen at the same time, concurrently, which is very difficult with log. You can query, while this was slow, what else was going on? So you can do this once. Then you can do performance dynamics, not only like in summary reports, mean, max, average, but actually, so all of these things. You can do whatever you want, analytics. And another thing which is not so obvious, but in my firm, it's actually very important usage, precise access control, because now you can not only trace who logged on and from where, but also which tables they access and what they queried and what they did. So it's like a very precise security control. So now design details. I'm conscious of time. So I talk fast, sorry. Stop me if too fast. Also, you know what? I'm the last. You won't have time to corner me in the hallway, so now I need to leave time for questions, right? OK, so design details. So yes, it's CSV, and it's obvious table structure. But there's several things which are not so obvious. So first of all, log ID. So when I said on Wednesday I presented the same talk in London, so there was a question, why you need unique ID? Because if you have session ID and you have the line in session, you get uniqueness. That is correct. But what you do not get the preserved order of records in the log. Because look at the log. Again, it wasn't one of the previous slides. By the way, I actually uploaded the slides. I've been good. I uploaded the slides, so you can follow me from the conference scheduler. The only way you can actually know what happened after was the sequence of lines is to literally record the sequence of lines in the log, because you can have hundreds of events happening at the same milliseconds. So first was that's why we need log ID. So my first naive solution was, OK, I defined big serial, and I load it, and just go on. Then second question, partitioning. So the log is growing. So again, I needed to have some generalization. My first approach to partitioning was partition by its horrible name. I might change it. I did not open source it yet, but it's called log sample time. But actually, that's the day. So logs are partitioned by day because we actually hope that we can archive them by day. We do not need them after some time, maybe. And then what were the problems? So one obvious problem, what is wrong with big serial? Oopsies, we lost one log file. And now everything is enumerated improperly. You cannot catch up. You cannot, oh my gosh. So what you need to do? You need to drop the whole partition, find a place where you missed it, and reload it again. So not cool. We do not want it, especially with some very large loads. So then what we decided, so even if we do this one, so that's what Miss Van Dog. So then what we, what we decided, so then the other thing is, if even we reload, how we can make sure we do not duplicate, because that was the other thing. So we wanted to make sure we can reload missing file, and we do not want to duplicate. So what we came up with, we decided to partition it even further. So each day is partitioned by log timestamp. And how we calculate log timestamp? We take the time log was created, make an epoch, round it to the nearest integer, because it's unlikely we will create several logs in 1 second. And that is our partition. So that is partitioned by log timestamp. So now life is relatively easy because we can drop this partition and insert. And remember with log ID, so now we drop the idea of big serial, and we built the log ID. So how we build it? We do this timestamp, multiply by 10 to the 9th power, and then we add the sequential number with this log. So what we have this way, first of all, it's 100% reloadable, and we always preserve the order. And even if we need to drop, oops, okay, there was an error with this file, we need to reload it, so we'll still get the right order, and everything is pretty solid. So that's my small but important design ideas. So then, next one, indexing. What indices we need? So obvious index, obviously, primary key, which is what we need for partitions, and log ID. Obvious non-index, and why I'm saying this, because when we gave users the permission to query this, like, can you build index by the username? Nope. You know why, right? Everybody here knows why. But I was like, oh yeah, no, we're not building no username, no client name. And then I kind of explained why you do not need it. You can just query these intervals and find all the users. But then another interesting thing, you want to query by query, right? And query is gigantic. And you do not know it's uppercase, lowercase. You cannot really build like B-tree on it. So you want to build pattern search by query. And when I tried it first time, Postgres said, I cannot do it. It's like too big, right? So the compromise we achieved with Postgres, that's the index I'm building. So it's a pattern search by lower first 1,000 characters of query. So anybody else uses pattern search indexes except for me, because I love pattern search. Okay. Thank you, Leticia. So I love it. It's super useful when you want to do like queries. And so that users would not go into trouble, because no sane user will write this. I generate search functions which have this built in. So the user actually gives me what they want to search for, and I transform it to this query. Okay. So now, next thing, security. I'm not giving talk for security because nobody likes my security talk, but I have to mention. I have to mention, right? I apply like one of my 4 security models, and we give each of our, so we have lots of internal customers in my firm, so each customer has their schema, they have read-only user, and so each log is a separate partition table, so they can use it. And for monitoring, we have a couple of monitoring tables, so which monitor the partitions which were created and files which were loaded, so we also can backtrace what we were doing. Now, examples of how we use it. Now, yeah. So first is tracing application. So same log, right? Like 100,000 begins, 100,000 commits, and we kind of think we know, but they do not want to admit. Some queries, what I'm doing with this log. So I'm selecting the processes, count the number of begins, and sort by the winners, okay? It's my results. Okay. So there are champion processes which have like 5,500 begins in one session. And what I'm doing then, I take this PID, because now I know who is the winner, and I query them, and that's what I get. Okay? Oh, yeah. So what we're doing here? Begin, select, commit, begin, select, commit, begin, select, commit, and 5,000 times. And obviously, that's our friend ORM, and even this ORM even has name. Who knows who does it? Huh? SQL Alchemy. Yeah. So just you know, they do not have the legit way to suppress read all the transactions. So our friend Alicia Kucharczyk recently found the way to fool SQL Alchemy, but technically that's what they do. So I gave it to the user. They said, oh my God, okay, we need to do something. So they went away thinking, but at least, I can tell. And also, by the way, this particular customer was super concerned about their performance. And they can even see how much each begin commit cost. It costs something, very small, but it does. So it slows down in addition to, creating all the other problems. So that's relatively easy, and I was suspecting this. So case number 2. And here I can relate to a couple of previous talks which were given today. When something was fast and then it becomes slow, that is like, we do not like it, but at least the usual suspects which we can check, okay? But I hate when customer comes and said, sometimes this is slow. Like, what are these sometimes when it's slow? Like, at the end of the day, early in the morning, every Sunday, every Friday, first, sometimes slow, like sometimes. So I kind of put this trap, start doing full logging and tell me when it will happen. I did for this customer, I did it a couple of times. Then they said, okay, yeah, this night. I did previous logging 3 days before, and that was like all good, all fine. Oh, they said it good. I actually did not think it's good, because it runs like okay, it runs like 40 minutes each load, maybe too much, but sometimes it's really, really slow. So just to skip a couple of things. So I found, and I know it might be small, like my slides are there, okay? I started from looking for the slowest query, and I found that the slowest query was create index, okay? And I've started to look, so August 14, it was okay. August 17, it was very slow. So that was first, it was slow between midnight and 5 a.m. So, okay, how this was executed between midnight and 5 a.m. So here you can see that it was executed like every 8 minutes of each hour, and it was kind of like consistent time. So same story, I'm querying it for the August 17th. And what I see here, you see the 2 a.m. it started way, way later. So now you can see something happened, and it actually went so late that it blocked the next execution. So there were 5 here and 4 here. Like, okay, all right. And this now, it's like, first of all, if this index is rebuilt 5 times during the load, something is definitely wrong. But now also it's like something was horribly wrong on the 17th. But now we know our PID, and now we can see what this PID is doing. And we know the good PID, good kind of, sort of. So what we're doing here, we are querying this good PID, and we see what it's doing. By the way, again, begin commit, but at least now it makes some sense. Some, right? So we're doing drop index, drop constraint. Who knows why they're doing this? By the way, any ideas why they're doing this? 5 times a night. Any ideas? What they were doing? Loads, yeah. They were doing loads. Now why they were doing this, and I just have a statement to make. Because still, not 30 years ago when I was a student, not like 20 years ago, but even now, all the textbooks about databases tell them before the bulk load, drop all indices, drop all constraints, then do load, and then build. And no matter what is this mass load, you might have like 100 million rows table, and you load 100,000, they still would drop, build, and who knows how long it takes to rebuild the index on 100 million rows. Okay. But they were taught like this, and that's so they come and they do this. And by the way, here, they dropped it before they figured out whether they need to load or they do not need to load. So just in case, because that's their process. So, but okay, here is like normal execution time, sort of, okay? Now, what was happening on the 17th, you see all of a sudden, drop the same index takes like 5 times longer. And by the way, you see commit takes longer. Everything starts to take longer. So what's going on? And I add on this drop foreign key constraint. Because, we do not run in this problem often, but I had it in my history of my relationship with Postgres, so I knew that is a problem. And the problem is that when you deal with foreign keys, the log which is put on the parent table is actually more kind of like serious than all the other logs you put during the process of insert and update and everything. And I started to search because documentation is silent about it. So, but I knew there was a problem. I started to search, and I found that one of the mailing lists. So, hi, why when I drop foreign key, it puts exclusive log on the table, on the parent table? And you know the answer, because how foreign keys are implemented in Postgres? Triggers, internal triggers, and both on parent table and on child table. So when we draw foreign key constraint, it's DDL, and because it's drop trigger, and that's exclusive log on the parent table. And what happened here? That all of these loads had one foreign key, which in the parent table was a table which had the files IDs to be loaded. And each time before the load, they needed to verify that it was loaded without any issues, that they have some data to load. So I said, and begin commit, right? Also. So, and begin commit for reads as well. So then I decided, okay, so now this other feature, because you can see what was going on simultaneously at the same time with the same period. So here is my query. I actually looked at this table, which happened to be parent table, and that's what I saw. And you see there are multiple PIDs. They are doing pretty much at the same time. Alter, drop, create, query, and all begin commits. So waiting. So I show this to the end user, to the customer. Is that, yeah, that's how a standard injection process works. That's what we do. Like, okay, developer, go and deal with that. I showed you what the problem is. So I was pretty happy with this solution. So now, it's all good, but now how we actually are setting this up. So, some people in Postgres community do not like me because I use too many functions and stored procedures. We are not blaming Magnus, but so I actually think it's good because at least then I know what people are executing. I'm responsible for this. I maintain this code and I know they will do what I tell them to do. So I have several functions to create this schema for a new customer, to create the log, to create partition, start loading, so everything is pretty much automated. But that was not enough, because some people know where I work and how I work, and we have we have way too many internal customers. We have over 200 production databases. We have less than 2 people supporting them. And when people are like, oh, we want logging, we need logging. So we need to have everything completely standardized, completely automated. So we did some brainstorming. And one of my fellow DBAs created the script which does everything. So for the script, we pass what is the name of the server where we process these logs, what is the host name and port for the customer who we want to process. What will be, is it a new customer? When we want to start, whether we want to run for specific time or we want to run it as a daemon indefinitely. And this script checks everything and does everything. It would call creating new customer and create a schema. It will call creating a new partition table. It will call creating partition. It will replace partition, and so on and so on and so on. If we try to reload partition at the same time, the same partition, it will be automatically dropped and recreated. Now, by the numbers, because one of the things, for several years I was, how I would put it politely, arguing with people because like, no, you do not do log mean duration 0, it will slow down your system. No, it does not. But then it will take so much space. It will take so much space. Sometimes, some of our internal customers, I can tell you why we are not doing it permanently for everybody. We have some created customers which generate more than 100 gigabytes of log every hour. So I'm not doing this. But we do like this spot tracing, and sometimes we enable continuous logging for the customers which have like reasonably sized logs. By the numbers. So this log, which I just showed, so it was obviously all my logs should be chocolate and ice cream, but that was actually modeled from the real log. So the log size was 2.2 gigabytes. That we logged 11 hours of work. It produced like 3.3 million rows, and table size was 1 gigabyte with this ginormous pattern search index. So actually that kind of compresses it. So the only problem you really need to take care of, that logs take space on the source system. So you need to make sure that you archive these files continuously. But other than that, it's all pretty reasonable. So now, what else? What are our next plans, future work? So first of all, I want to do more standardized reports because, again, users, when they figured out we can give it to them, like, yeah, want it. But you know what? Users are creative. So all of us know lots of ways how users can produce inefficient queries. So I am trying to create more standardized, not reports probably, but ways for them to query and to know what to do, not to do. I can remind as many times as I want, please address specific partition, but users are users, right? So that's my next goal. Then unit tests, and I try to do, if you ever saw my GitHub, I try really hard to do unit tests, so this is not pgTab covered, it's in my to-do list. So archiving strategy, that is something I've been advocating from the time I started it, and still use, no. So we actually need to develop standardized strategy, the same as we can enable it with one click, we also should enable archiving with one click. And the last one, you saw in my last example, I could only deduce that there were blocks, weights, but there was no indication. And that's something I actually want to talk to some people who are working on the recording weight events. Again, not pointing fingers, and I hope that I will be able to incorporate them. And actually, again, after I gave this presentation on Wednesday, there were questions, are you going to open source it? I hope I can, like a big part of this. Again, Jill's refused to work with me on this. But if anybody wants to work with me on kind of more productionizing, like packaging and everything, please reach out. I will be super happy. And reach out. So again, I'm Hetty. I'm everywhere on the internet. So like, find me anywhere. Ask me any questions. So we'll be happy to answer. Thank you so much. And I didn't time ahead of time.
Okay, thank you very much. Any questions?
So what's the problem with processing the direct PostgreSQL logs instead of getting it out of pgBadger? Why did you get it from pgBadger?
I do not get it from, I get it from pgBadger because I need parsing. So I did not want to create my parsing because I wanted to reuse the parsing with pgBadger used. There are like lots of things how they are parsed because it's not super obvious how to parse the log. I did not want to write my parser. That's why I wanted to politely steal it from Gilles Darrelt.
So just logging it from Postgres as CSV and directly inserting that into Postgres is not...
No.
You need parsing as well.
More intelligent parsing, yeah.
Cool. Okay, thanks.
More questions? Yeah, over here. Boris, I have a question.
You have a question? Okay, go ahead.
No. All right, I will use this mic. Isn't the impact on the system pretty big? To load the systems back into the system?
Yeah.
Isn't it a pretty significant impact,
on
especially
what?
on the disks?
On which disk? No, we are loading to a different server. So loading does not have zero impact on performance, or maybe it's like negligible, even like maybe fractions of milliseconds, because log is the file, it's not the part of Postgres, so it's like logged and logged. And then we FTP these files to a separate server.
That makes a lot of sense.
Yeah,
I thought the same users have access, so it is the same database, which is
No, but that's what they're saying. We have one centralized database, and we collect logs from all our 200.
Okay, thank you.
Thank you, Hetty. I'm also a huge pgBadger fan. So Certain Center preaching to the converted. I really like where you're going with this. There was one bit I didn't follow. It's like no indexing on... Was it username or client?
Yes.
What is it like? Is it GPDR? Like, why not index those?
Because it's indexed with very high selectivity. Because even in the systems which use security and grants properly, and there are very few, even in these systems, you might have like, I don't know, like 20, 50 distinct users' IDs, so indexing by user ID does not make sense. It's like inefficient index. That's all I'm saying. Because for each value in B3, you will have like many thousands of matching records. So actually, Postgres most likely will ignore this index, but why bother? Why create extra volumes?
Okay, thank you very much. Any more questions? All right, then I think we are done with the talks for today.
Cool.
Thank you very much.